Part 3 of 6 for the calculus exam breakdown of 2015. Question 2. The gradient of function f is given by f dashed of x is equal to 4x minus 3. The point 4, 6 lies on the graph of the function. Find the equation of the function f. Okay, so in order to go from f of x to f dashed of x, we've had to differentiate, or someone's differentiated. In order to go backwards, we need to anti-differentiate, okay? Because they want the equation of function f. So let's differentiate. Let's anti-differentiate, integrate. Got 4x goes to x squared. Divide the 4 by 2, because it's 2x squared minus 3x plus c. Okay, when you're doing just integrating like this, okay, it's not specific, you have to remember the plus c, and we need to find the c, okay? So this bit here, we've got x is equal to 4 and 6 is equal to y. In this case, the y is the f of x. So we've got f of x is equal to y, which means at x is equal to 4, our f of x equals 6. So we plug that in. 6 is equal to 2 times 4 squared minus 3 times 4 plus c. Four squared is 16. 16 times 2 is 32. 32 minus 12 is 20. 6 is equal to 20 plus c. So c is equal to, remember this has got to be a negative now if we shove it to the other side. So 6 minus 20 is going to be negative 14. Okay, that's not done yet because they want the equation. We've got all the parts of the equation, we just need to finish it off. So f of x is equal to 2x squared minus 3x minus 14. You done? See? A function g is given by g of x is equal to x squared minus 3x plus 18. That's pretty important. Find the equation of the tangent. So we're going to need to differentiate. And then we need to find an equation or create an equation that looks kind of like this. Okay. Where the gradient is 0. Okay, that's pretty important. So where m is equal to 0. That means all x's are going to equal 0 in the end anyway. But let's differentiate this and see what happens. So we've got g dashed of x is equal to 2x minus 3. That goes to nothing. So what does x equal when we make the gradient equal 0? X must equal positive 3 over 2 or 1.5. We're not given any y values. But when x is equal to 3/2, our g of x is equal to that squared minus 3 times 3 over 2 plus 18. Which should give us 15 and 3/4. So if we use y minus y1 is equal to m times x minus x1, doesn't matter what our x's are because the gradient is always going to be 0. So y must equal y1. So the equation of the tangent is going to be 15 and 3/4. Or if you're going to have that in decimals, it'll be 15.75. Okay? That's your equation. So what that's actually saying is that you've got your... So this is a parabola, and it's a... Whoops, sorry about that. It's a positive parabola. Whoops, that's an extra. And of course when the gradient is 0 is at the turning point, so your tangent, let's pick another colour. So your tangent just touches it there, so it's straight across. So the y value is going to be the same no matter where it is. So in this case, y equals 15 and 3/4, or 15.75. Okay? Okay. Whoops, I think I got carried away. I probably started describing what it was right here. In relation to the graph, so if the blue parabola here is what the original equation is, describe the point where the tangent meets the function. Okay. Well, we know here that it's a positive parabola, so we can say from the sketch we can see it is a minimum point. As the gradient is 0 and before it has a negative gradient and after has positive gradient. Okay, so you can say that, or you can easily make a little table and say at x equals, so at the turning point x is equal to 3/2, 3/2, which is 1.5. So you could easily say before that, which would be 1, at 3/2, and at straight after that would be 2. G dashed of x is equal to, and it will be some kind of negative number before and some kind of positive number before. Okay, So you can say here, let's just finish doing this diagram. So at x is equal to 1, our g dashed of x would be 2 minus 3 is negative 1. We know that this is 0. And at 2, 2 2's are 4 minus 3 is 1. Positive 1. Okay. So we know that this is a decreasing. This is turning. And this is increasing. Therefore, from table, we can tell. So this is before and after. And this is the turning point. We can tell this is a local minimum. Or you can say because it's a parabola, it's a minimum. Okay? And we're done. Thanks for watching.